In this section, we're going to discuss static members. Let's start with a problem. We'll assume a circle class, where it is important to know how many circle objects have been created. With what we know so far, it would appear that what we could do is create an instance variable called count, and when an object is created, to increment the value of that variable. So if I create two circle objects, each one would try to update that value, hopefully with the result of the number 2. However, this won't work because each object has its own personal copy of count. Each one would initialize and update its own copy. That means each circle object would say one more object was created, but it would only remember itself. So each object would have a count of 1, regardless of the number of actual circle objects. So this approach doesn't work. What we need is a variable that is shared, but no instance variable is shared. So the Java language provides for a way of creating shared variables so that there's exactly one copy of the variable available to all instances of the class. In other words, every circle object could see that one shared variable. Since each object has its own personal copy of each instance variable, these variables are not shared, but a class version or a class variable is shared. The way a class variable is declared is with the static keyword. It's declared similarly to an instance variable, except we have the static keyword added. And that static keyword means it's a class member that the class itself has the variable. The objects can see the variable and share it together. A different way of sharing, which is very awkward, is that the different objects would have to have references to each other and then ask each other to do some form of updating or coordination. This becomes a nightmare. Don't try to come up with a clever scheme of having objects talk to each other. Use class variables. Since a class variable has only one copy, a constructor should not be used to initialize it. Because the constructor is called each time an object is created, that means that shared variable would be initialized each time an object is created, overwriting previous values. The way to initialize a class variable is to do it right where it is declared. We use the assignment and we give it its initial value. In this case, we say static int count assign 0. When the class is loaded, this initialization occurs before any object can be created. By the time an object is created, the shared variable not only exists, it is initialized to the correct value. That means the first object that's created can use the shared variable without problem. To solve our problem of keeping track of how many circle objects there are, we would now have the constructor of the circle object update the shared variable. Not initialize, update. The initialization already occurred when the class was loaded into the Java virtual machine. The code shows the constructor of a circle, and it's passed a parameter called r, which is the radius. The object's personal copy of radius would be initialized using the value r. It would remember what that parameter was. Each circle has its own radius. That's its instance variable. Count is incremented, saying that a new circle object has been created. Update the static or shared variable by saying count increment. After the first object is created, count would have the value of 1. This code shows both instance and class variable usage. And notice there's no distinction between them. There's no special designation whether one is instance or class. We just use them, radius or count. One beneficial use of class variables is defining publicly available constants. Math.pi defines the value of pi as a double and makes it available to anyone who wishes to use it. If this is done, remember, these should be constants so that no one can inadvertently modify the value. Class variables are accessed by objects the same way an instance variable is. Merely state its name, as we have here, if count greater than equal 12. No difference. However, if access to the class variable is done outside of an object of that class, we have to use a special notation of prepending the class name. An example will follow soon. Since a class variable exists before any object is created, it has to be possible to access that variable without any object in existence. That means access to a static class variable is independent of any object. It is considered an error to access a static member through an object. That is object name dot for the member access operator and then the static variable. Although the compiler will only issue a warning in that case and not an error, form-wise it is considered wrong. A method that accesses that class variable should also itself be declared static. The restriction is that static methods can deal only with static data members. They cannot deal with instance variables at all because the static members deal only with the shared nature of data at the class level, never the object level. So a static method can never touch an instance variable. The reverse is not true. Instance members can access static variables. Just keep that order in mind. Although defined in a class, an instance variable and a class variable are not accessed identically. We have seen examples previously of how they work. In an instance method, we just simply name the variable, whether it's an instance variable or a class variable. Outside of the class, we access them differently. Outside of the class, to access an instance variable, you need a reference to that object and then ask it to return the value of that variable, typically through using an accessor method. For a static member, we must prepend the class name, put the member access operator, the dot, and then the name of the static member. It does not have an object name, but it does have the class name. We see an example here of circle.getCount. Circle is the name of the class. Dot is the member access operator, and getCount is a static method that will access the static data member count and return its value.